All right, we're going to keep pushing ahead to Module 13. I know it's a lot of information, but we will have some extra time the next couple of weeks or week and a half to work on this. I don't expect you to work on it all at spring break, but if you choose to work on things during spring break, I will be responding to email and Canvas requests and doing some grading and that sort of thing. I don't have any big plans for spring break, so I will be available if you do need help, just as an FYI. Um, so we are continuing on with object-oriented programming, and we're going to introduce a new concept today called inheritance. And it sort of adds a slight level of complication to what we've already learned with object-oriented programming. Remember, the idea of creating classes is sort of like the next evolution of functions for us, in that classes are a construct of Python that allows us to do something quite powerful, in that it allows us to create a blueprint that contains both methods and properties, aka functions and variables, that live inside that class. And with that blueprint, we can create many replications of that object that share those characteristics. And it allows for a lot of power and flexibility. Inheritance takes that a step further and allows us to use that blueprint to create another class. So in other words, I can use a blueprint to create another blueprint, and the blueprint that I create using the original inherits all of those properties and all of those methods. And then I can add to those. So it allows me to create sort of derivative blueprints. And maybe a good analogy, if we go back to the idea of the class as a blueprint for a car, let's say. The car has, windows and doors and an engine, and it has wheels. If I take that car class and I say, I'm going to use that, and I'm going to create a flying car blueprint now. So it has all of those original things, the motor and the windows and the doors and the wheels and all that. But it also has wings, right? Or propellers, or whatever you imagine a flying car would need to have on top of that. So the car class still exists, and now I've created a derivative of that class called flying car that still inherits all of those original properties and then has some other stuff. So it allows us to do some interesting things. How often will you use this? Well, it really depends on how complex your programs are and what level of coding you're doing. And also depends on somewhat the level of interaction that you have with other people, because the more team-oriented programming you do, or group-oriented, or participating in open source projects perhaps, you will be using more of these kind of constructs than if you are just sort of the kind of programmer who does your own thing, because then you can choose what you want to use. So going back once again to our ATM model, this is the basis for assignment 13. Assignment 13, I'm going to give you a lot of structure code in the template. The template's already on Canvas. You can download it. And what we're going to do is I'm going to show you in just a few minutes how I filled in some of that structural code to make a functional program that demonstrates inheritance. And the way it demonstrates inheritance is that I've now created a class called bank account, or a class that represents a bank account. That class has a deposit, a withdraw, and a check balance method inside that class. And it also has the properties of balance and the name of the account. So all of the accounts have those basic things associated with them. As derivative classes, you'll see that I've created a checking account class. And the checking account class has all of these methods and these properties, but it also has a method called write a check, because you can do that with a checking account. And it has a property named check number. So each time you write a check, the check number will go up by 1. So each individual check has a unique number, which is trackable. That's what all checks do. And I have also created a derivative account called savings. Savings is really just a copy of bank account and inherits all these things and doesn't really add anything else. If I wanted to get more complex, I might add something like interest rate to the savings, or interest accrued, or something like that to a savings account. I'm not going to worry about it right now, though. Okay, so there's one piece of formatting that I want to draw your attention to. And this is just sort of like an aside. It's not a big thing, but you can print this sort of a user interface using left justify and right justify and a filler character, so that it looks like all the money is lined up over here, all the names are lined up over here, and this varies in between how many dots there are in between. But it looks nice, and it's a way to line it up. So the way I did that is that I left justify with the account ID number. So the number, and then 5 spaces over, I have a left justify 30 space, however many this takes up, plus a number of dots to equal a total of 30, with that on the left side. And then I use right justify over here so that my zeros all line up. So you can use that with a little bit of formatting, and I'll show you how that's done in just a minute. But I kind of wanted to just review it in a visual way so you could see what was going on there. So if we look at code, this is what you'll find in Canvas. It's got a lot of structure, but you're going to have to fill in everything, all of the methods and everything. So I've got an import statement. I'm going to import the time module, which is a new one for us, but I'm going to show you how I use that. I've got the class called bank account with the initialization method, a withdraw, deposit, and check balance. The properties will be set here inside of initialization. So I'll show you that in just a second. And then what you can see here is I've got 2 more classes that I've created. Class savings account. And what you'll see is it's got in parentheses following the savings account a reference to the bank account class. So what that means is this class, savings account, is based on that class. So everything this class has, this one also has, and then we can define additional things here. So the checking account, same thing, has a bank account as a parent class or a super class. And I have a write check method defined in here. So those are the classes. And then I have a number of functions that you are welcome to customize or use as is. I did this to save you some effort in terms of putting the program together, because we've already done this kind of work in this class. I don't intend for you to waste a lot of time retyping things. Okay, so I've got a few things here that allow us to easily put together. There's a main menu function, a show accounts function with no commands in it yet, so you have to fill that one in. A press enter function, which allows you to pause until the user hits enter, which is useful, and then it prints a number of new line characters. Of course, I could just do that like this also, right? That same character times 20. It just scrolls the screen to clean off any garbage that's on there. And then I've got a create account function that will ask the questions, but it still needs some work filling in and actually creating the account. We've got the list of accounts, and just like a playlist, right? Just like the playlist, we're going to use a list to hold the accounts. And you'll actually be able to add accounts to this ATM very easily. So we have a list of accounts that starts out empty, and then we've got a nice logic structure that keeps us going in the program. and gives us the menu choices. But you're going to have to, again, fill in the gaps here. So let's take a look at this once it's been sort of fleshed out and completed. And I'm going to go through it line by line. But before I do that, I'm going to run this. And actually, let's run the correct one here, because that's always nice. There we go. Okay, so you can see it creates a couple of dummy accounts manually there. And then I can add an account. Do you want a checking or a savings account? Let's do another savings account, other savings. Okay. And then it pauses and scrolls. I'll show you how to do that in just a minute. And then I can check the balances. Again, I'll do the pause and scroll thing. I can deposit money. Let's put money in the other savings account. Which account and how much? I think it should be on the how much question now. There we go. You deposited into other savings. And now you can see how the money lines up on that right-hand side. So I press enter. Let's see. I'm going to do something a little different. I'm going to use press enter here. Instead of automatically scrolling, I can have it wait for me. So if I want to check the, I just wrote code up there, didn't I? Yeah, I did. There we go. Didn't want to mess that up. But if I check the balance, so now I have it waiting until I hit enter. So that's another way of sort of cleaning the interface. And then when I hit enter, it scrolls several lines. That's the poor man's clear the screen in command line, right? Is just have a bunch of blank lines. You can scroll back up and kind of see what's going on there. So let's take a look at this code, and I'll kind of go through it so you can see what's going on. So again, line one, I'm importing time. Then I create the class bank account, and the initialization method here takes str name because I have to provide the name of the account when I create it. And you can see here, it starts with str name. I'm going to actually start each account with 50 in it. Why not? Let's be generous. So when I create any bank account class, it creates those two things. And then I have a withdraw method. And just like before with the ATM, I'm checking to see if the balance is greater than or equal to the amount we're taking out. If it is, then we decrement the balance by that amount. And you say you have withdrawn, and I'm using a string str format there. And remember, this formatting code 0:.2f will give me 2 decimal places. It forces every number into 2 decimal places. And then I'm also supplying the name of the account. And you can see here that I'm referring to the name of the account using the self.name. Anytime I'm referring to a variable of that class, I'm going to use self dot whatever the name of that variable or property is. So it substitutes those things in. If they don't have enough money, it says you're broke. And then sleep clear is a function that takes an integer that's a custom function that I created that pauses for a moment, pauses for 1 second, in fact. This is a float that represents the number of seconds, so I could go 1.5 if I wanted to, but it pauses for 1 second and then it clears the screen. So the deposit, same thing. except that I don't have to check the balance. So I'm just depositing. And again, I'm using string format to make it look nice, to give it a good message back. Check balance. If I want to check the balance of just that account, okay. Now I get into the derivative classes, and there's something new here that I want to point your attention to, and that is super. Anytime I use super with the parentheses like that, I'm referring to the super class or the parent class. So I'm creating savings account with a bank account as the super class, and in the initialization for savings account, it takes self and a name, and then the first line of that method, I'm referring to super dot initialization. So I'm calling the initialization of bank account, and I'm giving it a name. Why? Because bank account requires that parameter when it's created. So I have to pass that through to bank account in order for it to be a valid creation, because I'm creating one of these every time I create one of these. A little weird, but just remember that's just the rule. And if you forget the rule, you can always come back here in the video and look at it. And then it just says you've created a savings account, and it gives it the name, self.name. And I don't have to create self.name or do the balance, because this does that. The initialization of the superclass does that. Okay, now checking account, very similar. Again, calling the super class initialization and passing it str name, giving the feedback, and then I'm creating the first check number, seeding it at 1,000. Pro tip, if you start a new checking account and they give you checks, don't get ones that start at 1, because a lot of places won't take checks that start at 1 because they know you're a new checking customer and they assume you don't have any money. So if you want people to take your checks, ask the bank to start your checks at number 1,000. And then people will have more confidence that when you write a check that it won't bounce. Not as if you ever write a check. I mean, I only write a check like twice a year, so, and every time I have to try and remember how to do it. Has anybody else in here ever written a check before? Okay, well, this is way more than average. Most of my classes are like, what's a check? Anyway, so when we write a check, it's going to be the same thing, right? I'm checking to make sure the balance is high enough, and if it is, I decrement the check amount, I write the check, and then I go self.check number plus equals 1, because I want the check number to increment to the first check you write will be 1,000, then the next check will be 1,001, and so on. And of course, then if it reminds you that you're broke if you don't have enough money to write the check. Okay, so I created this little function called sleep clear. It's one of the common interface practices, and all it does is it uses the time module, which we imported at the beginning, the sleep method of that, and sleep takes seconds as a float. So I pass it the number of seconds as a float, which is a parameter for my function, and then I print 30 new lines, which scrolls the screen until it's all clear. Main menu, nothing interesting there, really. Show accounts is one that goes through the list of accounts, okay? And so for every account in the list of accounts, this is where I'm putting together that nicely formatted string with the periods all the way across and everything justified correctly. The way I'm doing that is I am using the index of that account, which is a random number that I picked, so that people can refer to it. I could have used just the regular index for LIS accounts, but I didn't want it to start with 0. I like it to start with 1. So I just am using an exterior index that I create. str1 equals a string of index left justified, str2 account name left justified, and then I'm passing it, so it's 30 comma and then a period as a string. And then again, we've got a number that's formatted, account balance, This, by the way, will turn account balance into a string because it puts it into a string and formats it. And then I write justify it with 20, filling it in with periods. And you can see here, I'm just printing these strings all concatenated or added together. And I can do that because they're all strings. And then at the end, I'm calling the press enter function, which is another custom function that I have here. All it says is press enter or return to continue, and then it prints a whole bunch of blank lines. Again, that's kind of a silly way to do it. It's much easier just to do this. Okay. And then I've got a create account, right? It's going to ask, we want a checking account or savings account. What should it be called? And then what it does is it will append to list accounts, append either a checking account or savings account, and passes it the name. This is where the object is created. So when this happens, when I add this to the list, it will run the initialization method of those objects, of the checking account or savings account, and also the bank account, because it passes that back. So it triggers a sort of domino effect of things being run, which also has the effect of printing out your savings account or your checking account was created. So, and then if we don't say something valid, like 1 or 2, then if we say it's not a valid choice, and then it automatically shows the accounts, and then it returns this variable. And so what happens is, you can see here, if I want to create an account down here, I've got LIS accounts, create account. Now there's a few of these that I haven't filled in. So let's go ahead and fill one in. Let's do the write a check one. Okay, so we will need to show the account. And we'll just pretend like they know you can't write a check from a savings account. But we'll list the accounts first. Oops, that's not, what is it, show accounts? I forgot what I called it. There we go. Show accounts. It's not what show accounts. And then I pass it the list of accounts. That's why. Because I'm being thorough here. All right, and then we will create an input, str choice equals input, which account do you want? And then let's say int choice equals str choice, and we're going to try to change that to an int -1. I'm not going to do any error checking there, but ideally you put that inside a try or something to catch that in case they put something dumb. And I'm subtracting 1 so that the integer choice now corresponds directly to the actual position, the actual index of that account in the LIS accounts. So now I'm going to do this, LIS accounts int choice. So I'm using that to index it. And then I am going to write a check. Str amount equals Actually, I'm just going to go hard here and just go FL amount. I'll change it to a float on the fly. How much is the check for? Okay, so we'll put that in there and we will put FL amount into that. So basically what I'm saying here is LIS accounts int choice will bring up the class or the object that is in that position, in this position in the array of accounts, and then it will call the write check method and FL amount. Now, if it's not a checking account, if it's a savings account, it's going to throw an error because this won't exist. So I probably want to wrap all of this in a try statement because there's a lot of things that I left kind of open there. So maybe we'll just do this. Try and accept. And then at least I won't crash the program if I don't do it right. So the nice thing about this is if you notice, like a lot of this is error handling and getting the data from the user and that sort of thing, but actually writing the check, which involves checking the balance, taking the balance out of your account or taking the amount out of your account, incrementing the check number, printing the user feedback, that's all happening right here in this method. So I've made it pretty easy on myself to code that. Now, if I wanted to, now did I? Yeah. See, what I could do in write check is I could ask them those questions inside that method, and that might even be a better place to put those because then my code down here is going to be really clean and really simple. So that might be a better design choice. But since I didn't have it up there, I do have to get the amount and the checking account that I'm going to use. So all that to say is this gives you a pretty good sample of things. But the idea is for this assignment, you're going to fill in to make this a fully functional menu at least. And then if you want to add any other features or functionality, you can go a little bit further. So any questions about any of that? I know it's a lot of information, it's sort of abstract, but really, truly, object-oriented programming is something that is better learned by doing it than by watching it or hearing about it or just reading about it. So I encourage you to get your hands on this as quickly as possible so you don't forget.